So let's continue with our work on GCF. I have some expressions here, and we're going to try and determine the GCF and then factor out the GCF. I'm going to show you how to write that. So we're looking at this first one. It has two terms. The first term is 4x. The second term is 12. And I know from my my arithmetic tables, multiplication tables, that the GCF is 4. If you have trouble with that, you can go off to the side and you can look at the prime factorization of 4, and you can look at the prime factorization of 12. And of course you can see what they share in common is 2 factors of 2. Okay, so the GCF is 4. So how do you work with that? How do you write it down? Well, you're going to factor this binomial by putting the GCF out in front of a set of parentheses. And then you're going to figure out what goes in these 2 spots inside the parentheses. And the way you find that is you take the first term, divide it by the GCF, and see what you get. That's what I'm going to put in the first position. Then you move to the second term, which is a positive 12. You also divide it by the GCF, and whatever you get there is what goes in the second position. And it was a positive 12, and so this is going to be a positive 3. So there's your factored form with the GCF sitting out in front. You'll notice that if you multiply back together here by distributing, that multiplication should take you right back to the original expression. All right, so looking on these, remember that x here is raised to a first power understood. We agreed that we were going to go with the lowest exponent on the variables. So my GCF is x. And then in order to find out what to put inside the parentheses, you take the first term and divide it by the GCF. And in this case, we take the second term x and divide it by the GCF x, and that's going to give me a positive 1. So that is the way that looks when factored. And on this next one, I see a GCF of 5, and the lowest exponent is x to the second. Not sure why that's fuzzy like that. And I'm going to pull that 5x squared out in front as the GCF, open up the parentheses, and then I hope you'll get to the point where you can do this step in your head without having to write it down. Of course, here the 5's cancel out, and x cubed divided by x squared is x. And then the next one is a negative 15x squared, and I'm also dividing that by the GCF. 5x squared, of course you see that the x squareds cancel out, and negative 15, divided by 5 is negative 3. Again, multiplying it back together is a quick way to check to make sure it takes you back to the original expression. All right, here's one more of these. I'm looking at the numbers 8, 20, and 12. And I can tell you that the GCF for 8, 20, and 12 is 4. Again, if you can't do that in your head, you can go for that prime factorization technique. I'm looking for the lowest exponent on A, which is 1. And I'm looking for the lowest exponent on B, which is B to the third. So here's how you're going to write it. 4ab to the third comes out in front. I need a great big parentheses here. All right, so I'm taking it one step at a time, and again, you should practice trying to do this without having to write it down. I'm dividing by 4ab to the third, so 4 divided into 8 is 2. a to the first divided into a to the second is a, and b to the third divided into b to the fourth is b. Then I'm going to take the minus 20, a cubed, b cubed, and divide that by the GCF 4ab cubed. And of course 4 into negative 20 is negative 5. A into a to the fourth, a into a to the third is a to the second. And the b cubes cancel out. And the last term is positive 12 ab to the third. And again, I'm dividing by the GCF 4 a b to the third. And 4 into 12 gives me positive 3. And you'll notice here that the a's to the first cancel out and the b to the thirds cancel out. So that's the way that looks when we pull out the GCF. And again, for checking, you should be able to multiply back together here with the distributive property and see that that takes you back to your original expression.